let's start. So for this this week homework, we used credit scoring dataset. So this dataset we will use in week 6 when we will talk about decision trees. But I thought it's a good idea to already start using this dataset for a change. So you can read about this dataset here. So, I don't know. Yeah, it is. So this data set was used for some data mining course, I think in the University of Barcelona. Yeah. So yeah, you can read more about this data set if you want. But this notebook actually prepares this data set, so you don't need to prepare it yourself. So there is if we look at the original data set, it contains numbers, only numbers, and we need to translate these numbers into categorical variables. And I think one of these R files actually explains how to do this. So I just copied it from here. I think this processing. So it explains how to do this. I think this is where I took it, but anyways. So this is the pre-processing. So for all the categorical variables, we do some pre-processing. We don't do anything with numerical ones. Then the missing values are encoded with a lot of 9s in this data set. So we need to process them as well. So we need to replace them with missing values, and we immediately replace missing values with zeros here. Then we remove the clients for which we don't know whether they defaulted or not. And I don't think I said at the beginning that here we're trying to predict if a customer is not going to be able to pay back the loan. Okay, so that's the preparation. So we drop these customers for who we don't know if they defaulted or not. And then we finally convert this default variable, which is categorical, into 1s and 0s. So this is similar to what we did before with other data sets. And this is the notebook starter, and here you had an empty cell. So here it was your task now to fill it in. So I already pre-filled it a little bit. So for numerical variables, if we look at this data frame, so we have, let's take a look at head. So you can just look at this data set to see what is numerical, what is not. So home, marital status, records, and jobs are numerical. Home, marital status, records, and jobs are categorical variables, and the rest are numerical. Yeah, I think that's right. Home, marital status, records, and jobs, and the rest are numbers. And then default is our target variable. And that what we do next is we split, and this is, I just took this code from one of the other notebooks we have. You have seen this code many times. I will not go into details here. And then we come to the first question. So the first question was asking to use AUC to evaluate feature performance of numerical variables. So, and we, in the lectures, we use AUC to evaluate the quality of a model. So remember we had this, scores, the probability that customers are going to churn. Here, instead of using this scores, instead of using the output of the model, we're going to use features. So let's say we have this data frame train numerical. Okay. So for each of these features, we're going to use this feature as a score. But we're going to use this score to evaluate how good our model is. And model here means that we just use this feature as a model. So we're trying to use this feature as a way to separate positive examples from negative examples, people who defaulted from people who did not default. And for that, so let's try first with seniority. I'll just show you how it looks like. Seniority, okay. And then what we need to do, So yeah, so we need to import from scikit-learn metrics, import rock score, right? And then we use this rock score. So first we need to give it y train, and then we need to give it seniority, right, or some other variable. And well, maybe seniority is not a good example. Let's see what are the other numerical clones we have. I don't know, time. So you see that the AUC score for time is 56%. It means that we can, if we just use time as our score, we can treat it as a model, sort of, and this time variable can separate positive examples from negative examples with this AUC. So which is not super high here. And then with seniority, you see this is below 0.5. So remember in the lectures we talked about that it should always stay above 0.5. So here it's below. So what we can do here is we can just add a minus sign before seniority, and then it will turn it upside down, and then we will have we will so maybe what I will show you instead now is how it looks like when we plot this thing as a rock curve. So rock curve, right? And then a rock curve. So for the rock curve, what we need is y train, and now this data frame train seniority, right? And then it gives us so let me check. So it gives us false positive rate, true positive rate, and then thresholds. We don't need thresholds. We'll just take this, and we can just plot them. So we need to plot false positive rate, true positive rate. And let me make it square. So you see, it kind of goes below this random baseline, right? So here it means that the model for higher scores, for higher seniority, usually people with higher seniority have, they default less. So we can also see this when we look at, let's say, at histogram plot. So let's plot people with seniority that are churning, defaulting, and people who are not defaulting. And let me just use color here, color, blue, and here color red. So we see that for red, for people who are not churning, so they tend to have higher seniority scores, right? So they are higher. Then I think I want to use this plot. Yeah, so you see the scores are higher here, but if we reverse, so let's say if we add a minus here, so then scores for those who are not, for those who are defaulting, right, the blue ones, they become higher. So this is actually what we want to look at. So now let's just do this once more. And you see, this is how our rock curve looks like now. And we can do this for all the numerical variables we have. So for C in numerical, so we compute this rock AUC score between y train and our variable. So let's remove the minus here, C, and then print the column name and AUC. And here we see that for some of them, they are below 0.5, right? So what we need to do if AUC is less than 0.5, what we can do is we can just add the minus sign here. Right, and then we see that the highest one is seniority, right? So it has 70% AUC. So here the question is, the answer is seniority. Okay, now question two. Question two asks us to train a logistic regression model just on some of the features. So let's take these features. So let me copy them. Features. Yes, and then what we do is we use like the usual stuff. So now we need to turn our data frame train features to dictionaries. So we have them here. Yeah, so these are our dictionaries. And then we use our dictionary vectorizer, which I need to import from scikit-learn. Feature extraction import dictionary vectorizer. So we don't need sparse matrices, sparse false. And then now let's use fit transform, and then we put our dictionaries, and this is our X train, right? Oops. And then what we do next is we train our model. So our model, they also need to import it from scikit-learn linear import logistic regression. And then let's train it. It X train, Y train. So we trained the model, and now we do the same thing with a validation data set. So, validation. So it's XML. So here we do transform. It's important. I saw that many of you had this error that when you try to apply your model, and then it says, okay, I expected this many features, but I get less or more features. Usually this is because you have like you fit this dictionary vectorizer again. So yeah, I don't think I missed anything. So transform, and then we need this ypret, which is model predict probability x validation, and then we get the second one, right? And then we compute compute AUC, right? So for AUC, the first value is our target, our actual data, and then prediction, and then it shows 81%. So 81% is the correct answer. So let me quickly check if there are questions. Okay. Okay, I don't know if something is wrong with my YouTube or there are no questions in the live chat. So let me just reload it. Yeah, it seems there are no questions in the live chat. Okay. Sure, let me just double check. Yeah, okay. So this is the correct answer. So let me check what is the next. By the way, here I remember that some of you had a different problem. So here, let's say if instead of predict probability, you just use predict, what you get here is ones and zeros, right? And if you, let's say, if you use this as your predictions when you compute the AUC. So let's say you try to compute your AUC here, you get a score that is significantly lower than what you have, and like one of the options. And you can also look at the RUC curves. So let me just copy this code here. I want you to see how this RUC curve looks like. So, okay. So for the first one, we use Y validation, then we use Y prediction, right? We plot it. And then we use it again, but for this binary. Now you see this binary one looks like that. So this one is our binary. So there is this thing here, right? So here, these are all ones, right? So this part, and these are all zeros. So there is only one threshold. I don't know, it could be 0.5, right? And then, yeah, that's why, let's say if it takes all the predictions for 0, there is no way to establish order here, right? That's why it looks like a straight line. So this is not a picture you want to see. So if you see a picture like that with, this thing here, then something is wrong. Probably you're using predict instead of predict proba instead of getting the score. So the ROC curve should look like that, should be more round. So there should be no angles. And for the next one, I think it will take too much time to type. That's why I want to copy the code. So I have this solution here. Let me just, this is not the solution. So this should be the solution. So I want to copy some things because they will be just too long to type. So what I want to copy is this thing, confusion matrix. So remember, this is the code for iterating across all different thresholds. This is what we use in the ROC curve lecture, right? So here I don't compute ROC. I don't compute this through like FPR, TPR, I don't compute them. So I just compute the different values of the confusion matrix. But the code is actually the same one. And so now let's create this dataframes course, and then I'll use this this function here. And what we want to do now is we'll use these predictions here. So the first argument is validation, our actual values, and then our predictions. And then we have our data frame with scores, right? So you saw this in the lectures. What we want to do now is we want to create two new columns here. So one column will be a column for precision. I'll just call it P. And for precision, so the formula is true positives divided by true positive plus false positive. And then for the call, it's true positive and then true positive plus false negative. So now data frame scores. If we look at the scores, now this is how they look like. So there is this not a number, I think, because we try to divide by 0. That's why. And now we can just plot it. So plot. So first we plot the threshold, and then let's plot precision, and then we'll plot the recall. And we see that they meet at this threshold at 0.4. So usually, like let's say if we, the problem with precision and with recall, they are conflicting. So we can see it here that, so let me just annotate it. So for, this is precision, it is growing, it's always growing. So when we increase our threshold, so each time we increase our threshold, the precision is growing. On the other hand, when we increase our threshold, the recall is not growing, it's going down. So they are always in conflict. Right? And if we want to achieve optimal precision and optimal recall, one of the ways of doing this is to find a place where they intersect. And for us, it's around 0.4, slightly less, I think. And actually, this is the reason the F1 score exists, which we will talk about. Let me quickly check if there are any questions. Okay, I think so. There is a question, why did fit transform cause an issue? I think I answered that question already. Okay, so let's go to the next one. So for the next one, it asks to compute F1 score. So the reason F1 score exists is again the same as like the problem here is that precision and recall, they are always conflicting. So if we improve precision, recall drops. If we improve recall, precision drops, right? So they are always in conflict. So F1 score is a way to try to bring these two metrics into one single metric. And then instead of trying to optimize for both precision and recall, we just optimize, meaning by optimizing, I mean selecting the best threshold. So for us here, it was one way of selecting the best threshold, but F1 score is a different way of doing this. And yeah, let's do this. So here we have the formula, and I'll just implement this formula now. So it's 2 times precision times recall divided by precision plus recall. And now we just do the same. So we simply plot this. I mean, you don't have to plot this. You can use the max function. I saw in homework that many of you did this. You just plotted you just did the max. Yeah. So, and we see that it's around, so this is the maximum, it's around 0.3. And, I can also show you how you use max here. So let's see, max, just return the max, and we can use argmax, which returns the, oops, I don't think. Yeah, so let me just, we can set index to threshold and then do F1 argmax. I think this is, okay, I don't remember what you did there, but I saw in some of the examples that you did this with code. But yeah, I think with plot, it's also easy. 30, I think, means that yeah, if we just do dataframe scores, iLock, then we will see this one. Yeah, so it's threshold 0.3 exactly. Okay, cool. So now the next one about, so let me just quickly check the live chat. Yeah, I think somebody wrote that. Yeah, cool. So let's take the next one. So for the next one, I also want to copy some of the code because this is just too long to type. So the code I want to copy is this for training and prediction. And this is actually the same code that we used for the cross-validation session. I don't think I changed anything here. Now maybe max iter, so like that. I think this is what we needed to use. Yeah, right. Check if I don't miss anything. So liblinear, C max iter. Okay, and what we want to do now is we want to understand what is the standard deviation of the scores across different faults. So for that, first we need to import this k-fault class, scikit-learn, model selection, import k-fault. Okay, we did that. Then we create a k-fault. K-fault, so number of splits, was it 5? Yeah, 5. Then shuffle true and random state 1. Yes. Then what we do next is we iterate over these different k-faults. So for train, index, validation, index in this k-fault split, and we split our full train data frame full train. And then here, yeah, it's too long to type. I'll just copy it here. So here we get our data frame, a subset of the data frame, full train data frame for training, then for validation, right? We do it with ilog. Then we get our default variables like y train, y validation, and then we use the train function that I just copied here. Yeah, and we pass 0.1 because this is what our task was asking to do, 0.1. And then we do predict, which is this thing here. And when we return the prediction, and then we compute the AUC score, right? And then here we compute the mean, we compute the standard deviation. And standard deviation is, okay, name columns is not defined. Okay, should be features probably. Okay, let's see if I forgot anything else. That's weird. Probably, yeah, underscore. Okay. Let's see. Yeah, what I forgot is scores. So it should be, I should create an empty list with scores where we will put scores. Okay. Yeah, finally. Oh, no error so far. Okay, cool. So here we have this. So we have yeah, so we're interested actually in standard deviation, right? So not mean, and standard deviation shows us how different the scores are for different faults. So let me also plot. No, not plot, shows scores. You see that this is quite low actually. So you see they're kind of so there are ones that get 82, there are ones that get 78, there is one that gets 80. So on average, they're good, and this shows us how different these scores are across different faults. And of course, what we want to do is we want to have a model with low standard deviation. So when it behaves in the same way across different faults. So here the model, it's okay, but yeah, it gives us some idea that you know, like it's not as stable. So there is 1.5%. Yeah, and here, yeah, I think it's slightly different, right? So I don't have this option here, and the reason is that on this tablet, so I'm running it from a tablet, I use a different version of scikit-learn, and I think many of you saw this as well. So that different version of scikit-learns actually matter. So to me, it was a surprise. So I didn't do this to confuse you. So for me, it was also a surprise. And actually, this is something we will talk in week 5 when we talk about fixing, keeping the dependencies the same. So when we update, let's say, when we update our scikit-learn, we don't have this surprise that our model performance all of a sudden changes, right? So it's always a good idea to keep your version fixed. So in this case, I prepared this homework on my Linux laptop, on my Ubuntu laptop, and it used an older version of scikit-learn. And many of you also saw this problem. So here, yeah, it's slightly different still. Like if you answer this is the closest one, right? So this is the correct answer. Yeah. And then the last one. So here, what we need, maybe before I check the last one, let me just check if there are any questions. Okay, I don't see any questions here. So let's do question 6. And for question 6, we do the same thing. So let me just copy it here. I'll also copy default. So now let's do, let's iterate over different values of C. I'll also print C here. I think I didn't miss anything. Let's see. That's interesting. Okay, yeah. So I think this shows that this question wasn't as well thought through as it should be. Yeah, actually, yeah. So here I have a mistake. That's why it's. But I know that many of you had a problem with this one again for the same reason as here. So here you see that on this machine that I have here, so the answer will be 1, right? But if I run it on my Ubuntu laptop, the answer will be 10. And the reason is that so here I use a newer version of scikit-learn, and on my Ubuntu laptop, I have scikit-learn of slightly older version. That's why for this one, I will accept both these answers. So I think I looked at the answers and then it was like 50-50, or like 40% of people answered this one, 40% of people answered this one, and then the rest were these ones. So I will accept both this and this one, and it's just a note for me to think about cases like that and try to make sure that the version of Python doesn't affect the results. But yeah, so for this one, so this is the correct answer, and this is the correct answer. So both of these are correct. So what else? I think that's it. What I also wanted to talk, there was a discussion in Slack about the precision recall curves. There is this explore more session that talks about, suggests to look at precision recall curves as well. So I want to quickly show you this. So precision recall curves is when we plot recall against precision. or precision against recall. So this is similar to ROC curves, but here instead of the TPR and FPR, we look at precision and recall. So on the x-axis, we have recall, and on the y-axis, we have precision. And this is how our precision recall curve looks like. So here it's a recall, and this is precision. And actually, like the area under precision recall curve, I think it goes here, like at 0.2 here, 0.1, 0.0. So this is also a useful metric for evaluating binary classification models. Yeah. So let me remove all that. So this is how precision recall curves looks like, and the information it is telling us. So let's say if, so this is again recall, this is precision. Let's say we want to have 0.5 recall, right? What will be the precision for this level of recall, right? And then we know if we want to be able to identify 50% of defaulting customers, then our precision will be 60, slightly more than 60%, right? So this level of recall, we will find 60, the precision of our model will be 60%, right? And then we see that, let's say if our recall is 2, then, yeah, so we basically lower the threshold. We predict more customers as defaulting, right? And then we, of course, I think like this is the, we actually predict less customers, fewer customers as defaulting. That's why our precision grows. And let's say if we talk about 80% of recall, so then we lower our threshold, and then our precision drops, right? So this tells us, this gives us some idea, like how well you know, our model behaves. And here, I think the ideal spot is somewhere here, like 100% precision, 100% recall. And then again, we can calculate the area under this precision recall curve, and it's also a good measure of a good way of evaluating binary classification models. So let me check if there are any questions. So let me. Okay, so this is our Slido. Okay, how many submissions were there this week? I think I said at the beginning, slightly less than 200. Let me just check it again. 184. So last week it was 200. This week it's 20 less. So I hope it wasn't too difficult. Okay. Can you explain more about what JSON is when we use post and more on general use cases of Flask? I think I'll keep this to the end. So actually, let's talk about week 4 questions first. Do we need to scale numerical features for logistic regression? So the answer is it depends. It depends on the data set. So what you can do is, why so many questions about Flask? Okay, so what we do is typically we have this train validation split, right? And you try, first you try with scaling, then you try without scaling, and then you see what happens. I think this is something we talked about last week. And actually, if there's a notebook that I prepared for the last week, so we can go to classification, and the notebook is this notebook scaling, and it shows you how you can scale your features. Yeah, so this is, you can use standard scaler, you can use min-max scaler. Let me enlarge it. You can use these 2 different scalars, and it shows you how you can do this. And for this particular data set, it turned out to be a little bit better. And yeah, so you can just experiment and see if scaling makes sense or not. For linear models, it usually sometimes it's actually a good idea to do this, but you add extra complexity to your pipeline. So now instead of just doing this dictionary vectorizer and whatnot, now you also need to add an extra step of scaling. And then instead of basically now you have more steps in your prediction pipeline, right? And it becomes a bit more difficult to maintain. So I would say that scale if you see that the improvement you get is significant, because maybe it's not worth the extra complexity that you get. But again, use cross-validation, use your best judgment, and see what makes sense. Yeah, so again, last question. Is there some function or library to recode the categorical variables automatically instead of the math method? Just imagining doing this for 100 variables. Maybe, I don't know. Like, I think if you put this, you still need to have some names, right? I think the question is referring to, let me open this. So I think the question is referring to this part here. Where it is? Come on, okay, this part here, right? So you need to know that 1 means okay and 2 means default. You need to know that 1 means rent, 2 means owner, private, and so on. So if you have this information somewhere, then you can simply, it can be JSON or CSV file, whatever. So if you have this some information somewhere, then yeah, you can just load this. So this could be stored in a JSON file, right? And if you have that, then you can just use that. But again, you need to know that 1 stands for rent, 2 stands for owner. If you don't care about this, like machine learning models don't care, like they don't care if it's rent, owner, or if it's 1 or 2. Right? For this case, you can just turn this home variable into a string by using, let me show you. So you can turn it into a string by using something like that. Then it will stay encoded as a number, but it will be a string. And then when you use a dictionary vectorizer, it will treat it as a string, not as a number. So I hope that answers the question. So we do EDA on initial data frame or on data frame full train after splitting. What is the correct strategy? So the correct strategy would be not to include, not to look at the testing data set at all, right? So yeah, usually, let's say when I do EDA at work, so I have, let's say I use a SQL query to get our the data frame, the data on my computer to do some initial analysis. So in this SQL query, I select only rows that I need for the training. So I don't look at test at all. And it's generally a good idea not to look at test at all, because when you do this, this is called data snooping, and this is bad because it might influence your decision, and you don't want to do this. You don't want to influence your decision because maybe you saw and it looks like, okay, if I do this thing, it will become better, but maybe this is not really, like, this is not the real pattern. And when you see a new data set, this pattern that you accidentally observed yourself is not true, right? So try to avoid snooping as much as possible. So use testing only first to test your models, right? So don't avoid looking at tests at all costs, basically. So Flask. Okay, after the beginning, the beginning part of the precision recall model shows some rapid changes, and the later part of Rockow curve shows similar rapid changes. Why is that? Okay, I am not sure what you're talking about. Let's check. So close this. So rapid changes. Where are the rapid changes? Yeah, I don't know. But yeah, maybe let's talk about this in Slack because for me now it's difficult to understand. Okay, yeah, probably if you just share a picture and then we can talk about this in Slack. So question from Adonai. How can we train on encoded features as tick vectorizer or one-hot encoder using sparse true? Are there such use cases? Yes, of course. So you train it in the same way, exactly the same way as with sparse not true. So let me just show you. So let's say sparse true. And you do that. And I think the code shouldn't change at all. Yeah, so you see, it was even faster, right? So this is how we train on sparse matrices, and there are some advantages and disadvantages. So I just didn't want to go into sparse matrices for this course, but they are useful. And let's say, yeah, there was a question: what if we have 100 categorical variables? So this is the case when you want to use sparse matrices, when you have a lot of categorical variables, right? Because like if you use dense. So let me maybe draw it here. So this is dense, and then so you have let's say 0 here, and the rest are zeros, right? So this is dense, and yeah, so this is column number 0, 1, 2, 3, 4. And this is row number 0 and 1. So a sparse representation would be like for row number 0, you have 4 as 1, right? And that's it. And then for row number 1, you have 3 as 1. So you don't write here zeros, right? So since 4 out of 5 values here are zeros, you just don't write them. And this is when you use sparse matrices. Let's say, like I just came up with this, but I think it's a good rule of thumb. Let's say if 50% of these values are zeros, then you can just go with sparse matrix. Yeah, but actually, yeah, it was a bit faster. So yeah, so use cases when you have a lot of categorical variables. So many questions about Flask. So I'll cover some of these Flask questions. I think it's you really want to know something about that. Which different thresholds, or I don't know, with different thresholds, we also adjust distribution of target class for churn data. Churn and non-churn are not 50-50. I think non-churn is more than churn. Yeah, so indeed, that's the case. And so when you move your threshold, let's say, we talked about this here, like when we looked at precision recall curve. Let's say here, so when our recall, so this recall, this is precision. So when our precision is high, let's say here, so this is a very high threshold. So let's say this could be 0.7 or something like this, or 0.8. So precision is very high and recall is low. And here, like there are very few. So I think the distribution would be, so very few, like a very tiny amount of customers will be predicted as default. And the rest will be, okay, no default. So of course, like again, you use your best judgment. If for this model, it's really important to be precise, but you don't care about identifying all defaulting or churning users, then you can set a higher threshold. But of course, it changes the distribution. So, this. Can you remind us of the price of the first 100 in leaderboard? Glory, that's all. So there is no other price. So just put, if you want, of course, if you're one of these 100, and if you want to put your name there, I'll just create a page on the course page with your name, and yeah, that's it. So name and any link you want, like LinkedIn or Twitter or whatever, and that's the price. So there is, and everyone who took 2 projects will get a certificate. So you don't like, it's not just the first 100, but anyone who completed projects will get a certificate. Okay. If 2 numerical features are highly correlated between each other, shall we drop one of them? Use cross-validation to check that. So if you're on validation, you get better score. If you drop one of them, then go for this. Sometimes it makes sense to drop even if there is a decrease in your score, simply because maybe one feature is more complex to compute than another one. If there is an unbalanced data set, do we need to add parameter class weight to logistic regression model? How to add it properly? Again, the answer is the same. Use cross-validation to find this out. So try with different weights and see what makes sense for your particular data set. Is time not a categorical variable because it has only 11 values? I don't know. I haven't checked that, to be honest. So in the where I took it, so I took the data preparation step. I didn't see any data preparation step for time. So maybe it is a categorical variable. So I don't know. What is the reasoning of using AUC for comparing features rather than feature in target? Is there any mathematical reason, intuitive notion behind it? Yeah, so this one, oops, I marked it as answered. So for this one, I think it's just a good way of checking feature importance. So there is no mathematical intuition behind that. But you can think of, let's say, before you even train your first model, you can do that and see if there are any features that already give you good separation between positive and negative classes. Right? And if you remember about the intuition of AUC interpretation, that AUC is the probability that a randomly selected positive example has a higher score than a randomly selected negative example, right? And then here score can also mean a feature. So here, if a randomly selected positive example has a value of this feature higher than a randomly selected negative example. And if you think about this, then probably it makes sense, right, to try this. So let's say for seniority, so for seniority, it was like negative correlation. Maybe it's a little bit more complex, but yeah, so you can already see what are the important features, and maybe some of these features are already good enough. So maybe you don't even need a model. You can just use this feature as your prediction, roll it out, and then in your second iteration, do a proper model. So that's why, yeah, I think it's a good idea, and that's why I added this exercise. Okay, so let's go with week 5 questions. I think there are quite a few of them, and many of you voted this, so let me go through this. Do we need to deploy our model in week 5? Our country doesn't support AWS payment. No, you don't. You don't have to use AWS. You can use any other cloud provider. You can use Heroku, you can use Python Anywhere. Some of them actually support, like give you free, like you can deploy one thing for free. But this is just for your experiments. For homework, you do not need to deploy anything to anywhere. Oh, well, only locally, right? So the last question there is to deploy a model locally and score a customer. Right, so for homework, you do not need to do this. However, I highly encourage you to actually try deploying your model to the cloud. It doesn't have to be AWS. You can try to find something else that, I don't know, for example, for Google Cloud, they give like a couple of $100 for credit that you can spend on their platform. So they give it for free, and you can play with it and then, yeah, deploy your models there. So I highly encourage you to do that. Why didn't we use Streamlit instead of Flask? No reason. Just I think Flask is the most popular framework for doing this. It's relatively simple. So that's the main reason. Oops, I think I accidentally closed one question. So sorry about that. Can you explain more about what JSON is, when to use post, and more on the general use cases of Flask? So Flask is, let me just draw it. So let's say you want to create a web service, right? Web service, it gets some requests. So get request, post request, right? Any requests. And then a web service responds with something. Could be predictions, could be something else. It doesn't have to be related to machine learning. And to implement such a web service, you can use Flask, you can use Fast API, you can use any other framework for creating web services. So here I use Flask. You can use something else, up to you. But Flask just allows you to do that. And yeah, and when to use post, for example, yeah, let's say for get, you usually pass your parameters of a query. So let's say if we go to Google, if we Google test, then you see that there is Q equals test. So this is a request that parameter that we pass through get request. So this is a get request. But sometimes, let's say if you want to score your customer, then you don't want to put here, I don't know, gender, female, contract here, 1 year, and so on in string, right? So then you send JSON in post. So in post, you can also add some body into your request. So this is when you generally use post. Yeah, I hope I answered that. If not, we can talk about this in Slack. And yeah, so general use cases of Flask is to be able to create a web service. Why Flask and not Fast API? No reason. So if you like Fast API, go for this. Can you explain more on different Flask modules, when to use Flask, and what more to learn? I don't know much about different Flask modules. For machine learning, you probably don't need them. You just need plain Flask. And yeah, I think most of what you need as a machine learning engineer is in that course. There are not so many, but that should be sufficient, in my opinion. Maybe I'm wrong. I'm happy to talk about this, and we can do this in Slack. Yeah. So I see that it's time to wrap up. Let me check if there are. Let me just take the last one. I think I answered that. Models can predict non-term class more acquired. I have no idea what it means. Sorry. With respect to encoding, should we encode after splitting or split after encoding the entire data set? So as I said, take your test data, and put it away. Don't look at this at all. For your validation, also, you can look at this, but do not use it for encoding. Do not use it for anything. You only want to apply what you learned on the training data set. So let me write it. So this one, test, you take it and you hide it. So you forget about this. Then validation, you only do transformations here. So here you do things like fit and so on. And here you only do transform. So here you never fit anything on validation dataset. So you only fit things on train. So you fit your model, you fit your transformers, and transformer is like, dictionary vectorizer is a transformer because it has this transform method. Yeah, so you only transform the validation dataset. Of course, for test, you also transform. You don't train on this, but you hide it away. You put it away. You don't look at this. I think that's it for today. We should be wrapping up. Thanks a lot for joining me today, for asking questions, and let's talk in Slack. So have a great rest.